Hi folks, welcome back to the Frontend Engineer channel. This is the next series of the system design series for frontend engineers, and today we're going to look at the next problem called Google Calendar. So we'll try to design the Google Calendar. But before we go into this topic, please subscribe to this channel, hit the like button, and let's go. Alrighty, let's do the high-level overview of the problem. I've opened the Google Calendar, and as you can see, this is the application where you can create events, you can schedule events, you can invite somebody to this event, and it will be displayed in your calendar. For example, I can create an event for Friday, 1st of July, and let's say I want to record a video on this day. Here it's created, and the calendar can have multiple views. So the first, it's like we can see the year, and as you can see, we can dive into the month, and we can also dive into the day and see what will be happening on this concrete day. And yeah, we're gonna try to design something similar to that. And for that, let's go. So we have the pretty good overview of what we want to design. Let's go to the requirements section. And in terms of the requirements, I've populated the schema already in the system design just to save the time. And let's start with the general requirements for the design. So we need to support different views like year, month, and day. We also want to support the multi-user. This means that somebody can create event for us and also want to invite other users, and we need to receive the live updates. So this is not offline calendar, this is an online calendar. And we can also check the event view, open the event details, and also the one important thing, we need to make sure that we can spot the conflicting events. So for example, two events can intersect. One event can start, for example, from 7 to 8, and another event then starts at 7:30 till 8. And on the UI, we need to spot this conflict and show it to the user. Ideally, we also want to have export and import events functionality, because usually calendars can be used offline. And I would in this design we would focus more that like this app should be PVA. This means that user can use it offline, and ideally we also want to push the reminders to the user devices, no matter it's desktop, mobile, or something else. Yeah, that's the main requirements for our design. If we go into the functional requirements, you can guess that most of the calendars nowadays is used on the mobiles, and we usually use it on the go. And we need to think about our design mobile first, and this means that ideally our calendar works offline. Also, we don't want to waste lots of battery life, and and we need to think about efficient data model that we fetch from the server. Also, because we're targeting the web design, we need to think about how can we breach the native capabilities, meaning that is it possible to trigger if we want to set up a reminder, is it possible to reach the native alarm, to set up the native alarm using the web? This is also a good thing to consider. Another one is the efficient rendering. It's not going to be probably virtualization because we don't have the infinite scroll here, but we need to think about the user experience. We need to think how we can quickly switch from one view to another. How can we quickly switch the years and the months, so the user have the seamless experience in the animation and so on. And another point is the accessibility. We want our calendar to be accessible. we will try to cover also this topic. And let's think about the action plan. So how can we approach this design? First of all, we need to go through layout overview. We want to see the high level year, month, and the week components architecture, how this view are organized. So this will help us to understand how we organize the data in the future, how we pass the data to the child components, and so on. The next thing to consider is the data model and the API design. We need to think about the data and also the API. And the next one is the data transferring, how we transfer data, how we get the data, what is the efficient protocol for us, and yeah, this is also one of the crucial part. So the fourth point is the rendering optimization. As I said, we want to have the seamless experience in terms of animation, year changing, month changing. It's all should be smooth, and we want user to have the best experience. Then we will cover accessibility, notification, and how can we bridge to mobile, and also how can we optimize our application to reduce the load times, and so on. All right, let's start with the first one. We need to think about the layout. So we need to think about what we want to build. And here is the quick overview of the layout that we need to build. As you can see, for this design we'll cover 3 views. This is the year, month, and day. So for the year view, we have the view of the 12 months, and each month is represented by just a grid with the numbers. We can click on this on each day and open the events list for each day. Then we have a month view. So the month view is just a simple. It's almost the same thing that we have here for the year view, but it takes the whole UI space, and we can click on each day to see the list of the events that will be happening on this day. And the day view, which is just a simple list of the things like a schedule for of the events that are going to happen on this day. So this is a 3 main view that we're gonna focus on. We can also think about the week view, but for simplicity of this design, we can focus maybe only on these 3 views. All right, and in terms of the components architecture, we don't really need the schema at the moment, but I will use it later in the design to show the data flow and how we pass the data to each of the components. So on the upper level, we'll have the uproot, and we have 2 main subroot components. The one is the calendar controls and the calendar view. So the calendar controls will have all the controls that we need to create events, search for the events, configure the theme, configure the language, and so on. And the calendar view will have the main presentational model, the model that represents the list of the events that will be happening. And this calendar view have 3 main implementation. The one is year view, the second one month view, and the day view. And they will use kind of the cells. So the year view will use the month cell to represent a single month and the month view will use the day cell to represent the day, and the day view will just use the event cell. And each of this cell will use the event view. The event view is just a generic components for displaying the event information. And we'll also have some kind of client storage. The client storage is the global one. It will be the single source of truth for now. We can omit this part at the moment because we are not going to focus on that yet, but we'll look at that a bit later. So yeah, we finished with the main overview of the architecture, and let's think now. Let's think about data model that we will need to use for this system design. So in terms of the data model, Ideally, we want to use the same entities for all three views. This means that the entity should be universal. We want to use the same probably event entity, and we don't want to define duplicate information. Also, ideally, we want to be able to serialize this data and also deserialize this to support export and import operations. Well, this means that it should be JSON friendly. Also, we want to create, update, delete. So create, update, delete operations should mutate only the piece of data that we want to change. This means that we don't want to overwrite the whole store. We don't want to rebuild the data structures that involved in any calculations and so on. So, just to save the processor time and also do less CPU intensive tasks on the UI. Yeah, let me actually check if I started recording. Yeah, it's working. All right. So the next point is that the data should be easily accessible without additional operations. This means that if you want to mutate some event, we want to mutate it like ideally with O1 access. So we don't want to search for that. We don't want to do some, I don't know, complex logic to find it. And ideally, we also want the minimal transformation from the server representation. This means that the server model of the event should be close to the client model, and this will give us a simplicity on the client level because we don't need to transform the data in any way. And the sixth and the most important point is we want to support event conflicts detection and somehow understand that some event conflicts with another. For example, one event can span across multiple months, and we somehow should easily detect that this event is spanned across multiple months and it's conflicting with a certain date. All right, having this set, let's move to the types definition. So if we look at the first type, which is the first type is representing the whole calendar data store. I will try to stick with the simple approach. So this means that we will define minimal information that is needed for the design without diving into like some specific details. So the first one is that we want to efficiently store the event data that is coming from the server. And to do that, we need to store the events in a flattened way. And the best way to do that is to use the map, where the key is the ID of the event and the value is the event itself. So this will allow us to keep track of all events, and we can easily access any event by having only the ID. Also, we want to have some kind of client state. So the client state represents, for example, the selected view type. For example, we can have the year, month, and the day. And also we can have some configuration like the language, time zone, and many more. So this part is not really important for our design, but it's good to mention that this data just represents the client UI state. And so the event itself is represented, so it can have multiple fields, but I choose to have the ID, participants. For example, you can invite some user to this event, and the user info can contain email. Usually it's email and some other information like the first and the second name. And yeah, and also each event has this start timestamp and end timestamp. So we represent the date as a timestamp just to so because it's easy to get the exact date and time from the timestamp, we can convert it on the UI, and also depending on time zone, we can adapt to the time zone. And we also have a title. which is a string. Description can be represented in the rich text format. This means that we can, for example, use the links, we can use the images inside, and so on. And also there is an optional field called conflicting events, which is a linked list of IDs of the events that are kind of conflicting. So I'll explain how we calculate this later. But for now, let's actually think about the problem of the conflicting events. So see here we have, for example, two events. The one starts at 11 of June 2022 and ends on the 11 of July 2022. And the second event is 25 of June and it ends on 11 of July. So, and today is 30 of June. And as you can see, if today is the 30th of June, we somehow need to detect that on this date, we have two events. The first one is this one, and the second one is this one. So, and if we just simply imagine that if we store events in the array, and we just render the whole the events simply by going through all of them. And to determine that on certain date we have the conflicting events, we need to scan the whole array of the events and check if any events are conflicting. This is simple search operation, and it's kind of I wouldn't say this is costly, but it takes big of N to find, in the worst case scenario, to find the conflicting event. And if, for example, we have so year consists of 365 days. This means that we will need to accomplish 365 multiplied by N searches. That's not bad, it's not quadratic time, but it's still not the best case scenario. We can optimize that by, for example, trying to use the map where the key is the date and where the value is the array of the events happening on this date. This will give us quick access, but it will not. The problem that this map will introduce is that we will have lots of duplication. We'll need to, for example, if the event spans across the whole year, we need to push into the map 365 365 times, and this is kind of overhead, and I think we can do better. Here in the States, you see that I use the interval tree. So the interval tree is it's a special concept. So interval tree will allow us to kind of accomplish what we want, because interval tree is the special type of the binary search tree. But it works in a different way, and we can leverage the start timestamp and the end timestamp using the interval tree. And let me explain how the interval tree works in a hands-on example. So I have just a sec, I'll open the animation and let's go. So imagine that we have on the right side, you see that we have some 6 events that's happening in a different time. So they all have defined start and end date. So I haven't used here the time just for simplicity. Right now it's only the date, but it doesn't matter. We can use the timestamps and build the interval tree by the timestamps. So if we want to build the interval tree, so if we want to build the interval tree, it would look kind of binary search tree, but we will use the start date as the parameter that determines how we're building the interval tree. So let me show you the demo. So we'll start with the first event, which is 10 of June and ends on 16 of June. So, and when we build in the tree, this will be used as a root because this is the first one. And let's try to select another one. So as you can see, that we selected the another event, the 7th of June till the 14th of June. So what happens next? What do you think? How can we build the tree? So we'll use the start date as the determining parameter where this event will go in the interval tree. So because the start date is less than the start date of the root, this means that this node should go on the left side. So it went on the left. If the start date would be more after so if the start date of the node is after the start date of the root, then we would place it on the right side. So let's check what happens with the next node. So we select the next node. Let's compare the start dates. And as you can see, the start date is later than the start date of the root is less than the start date of the target node. So this means that we need to place it on the right side. So the next node, the next one is 1st of June till the 2nd of June. So let's repeat the process. We see that this date is earlier than the root. This means that it should go on the left. Then we see the next node, and we see that it's again less, and the start date is again less than the target node, and yeah, it should go on the left. So, and next one we choose the 11th of June and repeat the same operation. So the 11th of June is later than 10th of June. It goes on the right side. Then we select then we compare the 17th of June to 11. As you can see that 11 is less than 17. Then this should go on the left. Then we pick the last one, which is the 30th of June. And we repeat the process. Because it's later than the root node, it should go on the right. Then it's again later than this node, it should go on the right. So the tree is constructed. The next step of this is calculating the maximum. So for each node here, we need to determine the latest date, and I'll explain what is that. So here, as you can see, we check the bottom nodes. So we check this node, and it has two childs, and the end date of the left child is 2nd of July. The end date of the right child is the 30th of June. And we need to find the maximum of the childs for this node. And the maximum is 2nd of June. And here we see that this node has only one child, and the maximum for this node is 2nd of June. So this means that we determine the maximum of these two nodes, place it here, and now it is the max here. And also we determine the maximum between these two nodes, and it's the end date here. And now we need to find the maximum date of the root node, and we compare these two dates, and we see that the 2nd of July is the maximum one, and we place it here. Now the interval tree is constructed, and we can use this interval tree to conduct efficient searches. And let me show you the example how it's going to be. I'll return to the Draw.io. So let's imagine that, for simplicity, I'll just skip. So let's imagine that we want to search for the events that are happening on the 23rd of June. So what will be happening? So we go to this node first, and compare the target date with the maximum date. If the target date is less than the maximum date, this means that this range is present in our tree. So and now we can start our search. So because the 23 of the June is less, we first check the left node. So we check in the left node and see that. So and we basically see that here is the maximum date is 14th of June, and our target date is 23 of June, which is later than the 14th of June. This means that we don't need to go farther in this branch, and this will be the stop branch for us. So let's check the right child. So we're checking the right child, and we see that it has the maximum date of 2nd of July, and it still satisfies. And then we check the start and the end date of the event. Because there is no intersection with this date, this means this event is not happening on this date. And we continue the process of the search. We check the left child. We see that the maximum date is later than the target date. This also means that this node is actually satisfies our parameter, which compare the start and the end date of this node, and we see that this day is between the start and end of this node. This means that we need to pick this node to search for the event. And let's compare, and we check in the right node. So because the 30th of June is the maximum date, this node satisfies the first constraint. But when we check the start and the end date of this node, we see that we are not. So it's this event happening not on this date, and we just skip it. So the result of the search is this node. We have only single result. And let's try with the different data. For example, we want to choose the 13th of June, 2021. And we have the same tree. Let me just quickly deselect the color. All right, let's repeat the process. 13th of June. So the maximum date is 2nd of July. It satisfies the constraint because it's later than the target date. Then we check the node. We check the start and end date, see that this node satisfies all our constraints, and we need to pick this. Then we go to the left and the right child. So we compare the left child, see that the maximum date is later than the target date, and we check the start and the end date. So we check the start and the end date, and we see that this node also satisfies our requirement. And we pick this up. And then we go to the left node and see that the maximum date is 2nd of June. So it doesn't satisfy our requirement, and we just skip it. Then we go to the right node here, and we see that here is the 2nd of July. This date is later than the 13th of July. This means that the first constraint is satisfied. Then we check the start and end date and see that this node is not satisfying the start and end date constraints. We just skip it, and then we check the next childs. So the left child, the main constraint is satisfied 2nd of July. And we check the start and the end dates, and we see that this event is happening between the start. This day is between the start and the end of the date. This means that we need to pick this node up. And the last node, 13th of June, yes, it satisfies the first constraint. The maximum date is later than the target date. But the start and the end date, it do not satisfy our requirement. This means we just skip this node. And as a result, we have 3 nodes, have 3 events happening on this date. And during the construction of this event, during the rendering of this event, we can populate the conflicting events data here and later use it for rendering the conflicts. So what is the complexity analysis for this one? So if we look at the complexity analysis, so the search to render to render events for 365 or sometimes 66 days in a year, it will take 365 multiplied by a log n. Log n is the log n is the default complexity for such operation on the binary search tree. So the insertion and the deletion will also take the log n time, and this is much better than the n. And I feel like this approach would satisfy our performance requirements, and it also give us the really nice way how can we search the events happening on the certain date, and also how can we because we don't need to keep track, we can have just a normal interval tree of the all events in our app, and just giving the target date. For example, we're rendering the events for this date. It will give us the full list of the events happening on this date, and we can quickly see the conflicts if we have any. So this is the interval tree and how it can be used for your calendar. As you can see, we'll populate the events from the server or from the client. These events will be added to the events map, and we also will push the events to the interval tree. So in the interval tree of events is the client-side structure. So it contains only event IDs, and we can use this event IDs to access our global storage to the events map and then do any changes. For example, we want to change the event information. Then we just go to the events map and we don't touch the events tree. Events tree is just the container for event IDs, and we use only the start and the end timestamp. So any operation, so we will do any mutation, deletion operations only on this events map, and if any new events come, we'll just push it to the interval tree. This is the idea of the interval tree on the calendar. And now I think we can go to the data API and how, not the data API, but data model, data transferring. How can we design the API that can efficiently satisfy our constraints to be mobile first? So in terms of main protocol, we have a few options. And the first one is the long polling. So the long polling is quite easy to implement. It's just requests with a certain timeout. The problem, however, is the latency can be pretty long. For the calendar, it's not actually bad because the calendar doesn't require a live update. So consider this as a con, but it's not really a con for the calendar. So the connection timeout, especially because of the proxies, the problem with the connection timeout is that, for example, you go on the fast car, and you constantly changing the network stations. So the requests will have to go through several network stations, and this means that we might have the connection timeout, but it's also not a problem because calendar doesn't require the real life updates. So yeah, let's say it's not a con too. So also the traffic overhead, this is the usual normality with the long polling because we send the full request. Kind of the con for the calendar, that's true. We don't want to send the data, and we don't want to send require additional traffic. So this is a long polling. For the WebSocket, I feel like WebSockets are super fast. It can have duplex communication, but all the benefits of the WebSockets, we don't need that for the calendar. Because keeping the WebSocket connection is expensive, it's not HTTP2 compatible. Also, WebSocket's really hard to load balance, and because many things are done in HTTP2 HTTP2 protocol. We don't really want to implement this on the WebSockets level. Yeah, and kind of WebSockets overhead for the calendar, and the next protocol that we can use leverage in our, and I feel like it's a perfect one, is the server-side events. So the server-side events benefits from HTTP2. We receive only the piece of our of data that we need there for the. Yes, it's in a text format, but this format fully satisfies our requirements. Also, the SSE events don't waste device resources because as server-side events use mono antenna instead of duplex antenna. The duplex antenna in the mobile devices, it's kind of works for receiving and the sending the data, and it requires more energy. And the server-side events triggers only the receiving antenna, and this greatly reduces the load on the mobile device. So also service-side events are pretty easy to load balance in terms of the scalability, but it's more a backend question actually. So in terms of the cons, it's unidirectional, a bit weird API, no problem, and it has only, the format is only text data. Also fine for us. But in terms of, and okay, we choose the server-side events, but can we actually somehow improve server-side events, use the server-side events as the implementation of something, and with that have some convenient API that we can use? And I feel like the GraphQL here comes to the play. And let's just design first the API methods that we need for the system design. For the API, I will have only 3 methods here. The first one is subscribe event that will take API key, user ID, timestamp of and the period. For example, we can pass the timestamp of today and the period of the year, and we will receive the whole events for the year, or for the month, or for the day. Depends on how we want to subscribe. And this will subscribe us for the events that will be happening after. And first we'll receive a great chunk of the events, and then we'll receive only smaller updates with the live update. The next one is the get event info. For example, we open the event details, and we don't want it to fetch this by default. We want to preserve only. We only want to fetch the main information chunk. And to save the data, we can just simply use the short version of the events here, and use this method to get the full details of the event. And also we want somehow to mutate the events, like create, update, delete. And for that, we can use 2 mutations, the create event mutation and update event mutation. And I used the word mutation here because I already mentioned that the GraphQL seems like a good solution to this problem, and here is why. So the HTTP2 spec defines the server-side events. The GraphQL spec defines subscription, mutations, and root fields. So the subscription is kind of live fields that you can subscribe, and we can and the subscription can be implemented in the implementation of the subscription can be done on the client side. This means that we can implement the subscription using the HTTP2 protocol using the server-side events. So this will be GraphQL subscription over server-side events, and this sounds pretty cool to me. And the subscription can be also implemented on the WebSocket on a long polling level. And this, I feel like the GraphQL spec gives us a great flexibility here. Also, the GraphQL defines the mutation that we need to just create and update delete events, and the root fields. The root fields is just the entering field where we can start fetching our JSON. So in terms of what is the pros and cons on designing, on choosing the GraphQL architecture instead of the REST architecture. As I see that the GraphQL gives us high flexibility, you can request the exact piece of information that you need, and we still have all the benefits of server-side events. We still have the HTTP2, and yeah, we don't need to create multiple endpoints, because with the REST you will define the endpoint for the update, for the create, for the delete, for the post, for the get, and this on the server level it will. So you basically define more endpoints, and using the GraphQL we can have single endpoint, and we can fetch only the pieces of the information that we need, because GraphQL allows us to select the fields of the JSON that we need. And for example, if we want to implement a similar approach for REST API, this means that we will need to define the query params and, for example, enumerate all the fields in the query params that we want to select. And yeah, this will also, it will be also a bit pain to define such requests from the type system level on the REST, because for example, if you define the GraphQL response, you know that each field is selectable. But in terms of, if you define the REST API with the fields that can be in the response and cannot, and the fields that can be absent, this can be a pain. So also, what are the cons of the GraphQL? The problem with the GraphQL is that not all GraphQL clients implements the server-side events, and we need to implement this on our own. It's not a bad thing, but usually I would expect this thing to be implemented on a client level, because we don't really want to focus on that. But yeah, it's still a possibility that we need to implement this or to support this on the server-side events. Anyway, this is pros and cons, because the pro is that it's flexible, and we don't have HTTP caching. So the GraphQL works over the post request, so we need to rely on the client library to cache the requests, and this is the main problem of the GraphQL. And we don't have the default caching that we have with the get request with the REST architecture. So I feel like the GraphQL, both REST and GraphQL suits good here, but my personal taste is that GraphQL is much more flexible in this case. All right, so we choose the server-side events over the GraphQL. This is cool. And now let's see how we implement the communication with the server. Remember the schema I showed you last time? Now let's try to define how the event flow, how we handle the events and how we handle the data passing. As I said before, we'll use the client store. The application client will subscribe to the client store. There are many libraries that can handle this approach. This is called event architecture. When you react on some events, you have some event handler that reacts on the event, and then you update, you do the update operations, you do some async operation, and then update operation over the client store. There are many libraries in React. This is the Redux. On the Vue, this is Vuex, and there are, I think for Angular, this is NGRX, and yeah, there are many ways to implement how you can implement this. I will use just generic approach. This is called event-driven architecture. So the app root will have the init event that will go to the event bus. Event bus is just a default concept where all events go through the event bus, and this event bus pass all events to the event handler, and then this event handler will call the async action that will update the store. And once the store is updated, the app root receives the data, and then we pass it to the child components. So the calendar view will receive the events, and these events will be passed to the month cell, day cell, and event view. And also the event view can fire the load event details, and it's also get passed to the event handler. We'll load the get info and then update the storage. And again, this is the cycle. here, and this is how the application would work in our case. I'm simplifying many things here, but the general approach in the event-driven architecture that you have a client store which is global and accessible anywhere. You can the root subscribes to the client store, then data get passed down, or each of the component can subscribe to the store depending on the library implementation. And each of the component can fire an event that goes to the event bus, and then we just handle that. This is the way how we handle the client-server communication, how we update the data. All right, so the next point here is the rendering optimization. How can we optimize the render? And as I said, this is not the virtualization. So what we want to achieve is we want to quickly switch between the years and the months. Also want, because no virtualization needed because we don't have much elements. We don't really need any virtualization here. So the solution one is we just when we change the, for example, we change the year from 2021 to 2022, what we can do is we just can we do soft update over the text fields. And this is pretty easy to implement. We just update the data on the calendar. The main problem is that it might take time to re-render because the calendar can have different dates and the number of days, and we need to fetch the data, and we need to update this data. So, and if the user switch the years or months too often, this means that we need to do lots of requests and also do lots of re-rendering, which is not really good. But overall, I feel like this is one of the possible solutions that can be easily done. But there is a second one that I like more. So this means the pre-rendering. So we'll pre-rendering the previous periods and the next periods. So, and how the pros of that is that the previous and next periods will be already pre-rendered. What we need to do is just to use the CSS transformation to pull it on the screen. And the cons is that we render more elements, but we do less re-renderings. This means that UI is more smooth, and yes, it's a bit harder to implement because we need to implement the transitioning, but I see this as overall a better approach. So, and how it's implemented actually. So imagine that we have our year 2022, and we also render the year 2021 and year 2023 and place it outside of a user viewport. So this area and this area, they are hidden, and the only visible area is this one. And imagine that the user switched to the year 2023, then we'll just do some smooth animation transitioning, and we get this year get pushed on the left, and also the year 21 get pushed on the left too. So this is translate x minus 100%. This is translate x minus 200%. And we also pre-render the year on the right. So if a user decided to switch really fast, this means that we'll just pull the years using the CSS transformation because the data will be already pre-rendered. And we can define the maximum number of screens that can be on the user screen. For example, 10. This means that for example, 9. This means that we'll have 4 screens on the right, 4 screens on the left, and 1 screen which is visible for the user. I think like this solution is pretty good for us, and we can use it. All right, so this is the pre-rendering that we can use. The next one is how can we bridge to the mobile in the native apps. So bridging to the mobile is a bit tricky. We can do this in 2 ways. The first one is the push notifications. This means that the web API defines the web push technology that allows us to push some notification in the browser. And the browser, there is always a browser on the mobile device, there is always a browser on the desktop device, and we can reuse it. So the problem of web push is that we need to have a consent on receiving the pushes on the browser, and usually users say no. We also need to have the push server. This means that we have a separate server, or we can that can trigger the push events, and this is also additional architecture on the backend. And how can we do this? Is also additional service on the backend. And then another approach is using the deep links. So the deep links allows the application on the phone to handle certain links. For example, we can create a reminder that links to the certain app on the phone, for example, alarm. So this will require to have implementation of this link. This will require to have implementation of link handling on the native app, and not all native app can have this implementation. The link would look like this. I don't remember actually the format, to be honest, so but it may be. The link can look like this. This is the alarm app. And for example, they might be like create alarm. So this should be handled on the mobile device level, and not so the target app should support these links. So we are kind of dependent on the implementation of the link handling on the mobile device. This is the two way how we can bridge to mobile. If you know any other ways without using the native technologies, please comment this in this video. All right, the optimization for the calendar. Because the calendar is a web app, we still use the default optimization techniques, and you already know them by heart, but I will repeat them. So because we're using HTTP2, it's easy for us to bundle split, and we can split the bundle into the multiple resources. For example, some resources can be loaded later with the link pre-connect. We can also zip and throttle the resources. Actually, I know I did the typo here, and as I remember, this is the broadly, right? Yeah. So this is the broadly. This is the modern format developed by Google. It's more efficient than zip by 33%, and we can use it to compress our resources. So also, because we minify the resources, we split in the bundles. We can prepare several bundles for old browser, for the new browser. For example, we can prepare ES5 browser, that the ES5 bundle that imports all the schemes, all the polyfills, and we can use the ES6 bundle that will be more lightweight, but it will be for the newer browsers. So in terms of the rendering performance, I think we do already mentioned that we need to avoid reflows, and we want to use the CSS animation. With the pre-rendering, we can pre-render the stuff and just we're using the transform X just to move the stuff around, because this is just a paint. This is just a paint step for the browser. We just move in pixels. It doesn't cause any reflow, and it's really performant. And yeah, so also it's important to know to use the CSS namings. Also, we don't want to remove new nodes. Remember, if we go with the approach when we update each cell of the calendar, then we can just use the soft writes, and this is better than. This is much better than removing the whole node, inserting it, and this is not causing any performance issues. Yeah, we can load any analytics later. We can show while the app is loading, we can show some placeholders, and we can inline the critical resources with the web page that we are getting. So the other resources will be loaded later, and the user will receive the content as fast as we can ship it. So in terms of the JS performance, yeah, I already said that we optimize the operation over the store by mutating only the piece of data that we built, and also by using the efficient data structure that allows us to search quickly and also insert the data, and we don't really want to remove the nodes probably. Maybe if we delete an event, this is the only case when we modifying it, when we deleting it from the tree. But anyway, using the efficient data structure, we can minimize the mutation over the store, and yeah, we also want to minify the code, shape less polyfills, as I already mentioned. And yeah, because this is PVA, we want to use the application cache. We will cache all the resources that will require for this app to function offline. And with the web worker, we basically enable the offline usage of this app. So that's it for the optimization. And in terms of accessibility, I probably repeat this stuff over and over. First, we don't want to use any pixel stuff on the UI because it doesn't scalable. The user can have custom browser settings, and we want to avoid that. And we also want to introduce the hotkeys, for example, next and previous date period. We want to switch the period with the keyboard. We want to search for the event. We'll also want to have a keyboard shortcut for opening help menu, and probably want to provide color schemes for the people with a color blindness. Another critical thing is to use the correct area attributes. If we stick to the HTML5, we can minimize the usage of the area attributes, but the one thing that can be useful when you developing the calendar is to mark your calendar with the role grid. This will tell the screen reader that you're interacting with the interactive table or the grid. And yeah, we need to leverage the semantics of the HTML5. All right, I think we've covered most of the things in the calendar design. As usual, I'll attach the schema to the video, so you can check the schema and go through it on your own. And let me quickly switch to the default view. Yep, so thanks a lot for watching this video. I hope you like it. If you like it, don't forget to hit the like button. Also, I have a Medium channel where I post engineering articles, and a Telegram channel where I post my personal notes about career, and usually the announcements of the next videos comes first in the Telegram channel. I hope to see you in next videos. Don't forget to comment, suggest any stuff that you feel useful, and also if you want to cover some topics that are not present on the channel, feel free to comment this, and usually I read the comments and try to answer on them. And the more comments we have on the videos, more people can watch these videos, and this means that these videos can be more useful for more people. All right, folks. Thanks again, and I hope to see you in the next one. This was the second series of the second episode of the system design. I'm planning to prepare for more, so there will be 4 more series. Yeah, see you in the next one. Bye.